Hello students, in the last lecture we have started the topic photochemistry. In the photochemistry we know the basic concept of photochemistry. We know that the photon is the basic source of energy. These photons absorbed by the molecule or compounds. After absorption of this photon energy of the compound get increased, and these compounds transit means get excited from the ground state to excited state. But at the excited state, this atom or molecule or compound releases that absorb energy, and energy decreased. At the same time, it comes transit from the excited state to the ground state. Means all about the transitions. Transition means transition of electrons. Molecule excite means electron excite. This transition of electron from ground to excited state and excited to the ground state. The transition of electrons are going to be studied in the photochemistry. While transitions, some are allowed transitions, some are forbidden transitions. Means every molecule, every atom after absorption of photon of energy not get excited. Some are allowed transition, excited transition, some are forbidden transitions. That depends upon some criteria which we will discuss in the lectures. Okay friends, so the electron transitions are given by the selection rules. Selection rule decide the electron transitions. According to this rule, during the electron transition, this electron will be no longer no change of spin, and its spin multiplicity remains same. Means no effect on the spin multiplicity after absorption of the photon. Electronic transition involving the same multiplicity state, that is singlet to singlet or triplet to triplet, are said to be allowed transition. Electron transition involving the same multiplicity state, that is singlet to singlet or triplet to triplet, are said to be allowed transition. Means what happens? Spin multiplicity cannot be changed in the electronic transitions. You can understand it easily by here is the ground state, here is an electron, it gets excited to the higher state, ground state, the excited state. But here is the 2s plus 1 is equal to the x. Here is 2s plus 1 is equal to x. Means the value of 2s plus 1 means the spin multiplicity for ground state as well as for excited state. For the both states, value of spin multiplicity is the constant. Means no change in the spin multiplicity. That are the allowed transitions. The transitions are the allowed transitions. While these transitions involving different multiplicities are said to be forbidden transitions. means singlet to triplet, triplet to singlet is the forbidden transitions. Means if the spin multiplicity changes, the transitions are called as forbidden transitions. When molecule absorb light energy, it get electronically excited and goes from state to the S1 state, means S0 to S1 state. When the molecule absorbs the light energy, it gets electronically excited and goes from S0 ground state to excited state. But multiplicities remain same in singlet ground state, singlet excited state. If the excess energy is absorbed, it may go to the S2 state. These are the different states we can understand. For example, here is the ground state, it is 0 state, it is a 1 state, it is a 2 state. For example, it is the singlet means S0, S1, S2. Electron excited from ground state to excited state. This is the first transition. If it absorbs more energy, then it directly excited from the ground state to the singlet S2 state. Vibrational relaxations. Electronic energy levels are decreased and molecules of higher vibrational level in N1 state lose energy by collision and come to the ground vibrational state. That is the vibrational relaxation. Internal conversion means S2 to S1, S1 to S0. The molecule can lose further energy by collision and come to the ground electronic state, that is S0, by loss of heat. This is a non-radioactive process. Next one is the fluorescence. Vibrationally relaxed molecule in the S1 state may instant energy by emission of the radiation, and this process means S1 to S0 is called as fluorescence. Excited state to ground state is called as fluorescence. It is continue as long as molecules are exposed to the light. Inter-system crossing, that is S1 to S2, singlet to triplet state transition, interstate crossing. S1 to T1 transition is forbidden according to selection rule. However, some of the vibrational levels of the S1 state have the same energy as these of the transition state. These are the transition state. Okay friends, so these points is not in this topic. Yes, it is in the topic, but I am finding the some another points. I think while scanning one page is here missed. No problem, we will discuss it later on the next topic, this topic. Okay, next one is the types of reactions, that is Norris type of reactions. Generally, photochemistry involves the breaking, that is electron breaking, means it is a hetero homolytic bond fission. Means electron transfers radical mechanism going to the radical type of mechanism. So Norris type second reaction and Norris type first reaction are the two important reactions in the photochemistry. So we will discuss it on the detail on the next lecture. Thank you.